How long does a spaceship last? It's a question that might not immediately spring to mind, but it's a fascinating one. After all, these vessels are designed to venture into the vast expanse of space, far beyond the protective embrace of Earth's atmosphere. So, what factors determine their lifespan? Let's dive in. The lifespan of a spaceship, a complex equation. The lifespan of a spaceship is influenced by a multitude of factors, each playing a crucial role in its longevity. Let's break down the key elements. Mission duration. Short-term missions, spacecraft designed for short-term missions, such as those to the Moon or Mars, often have a relatively short lifespan. Once their primary objectives are accomplished, they may be decommissioned or left in orbit. Long-term missions, on the other hand, spacecraft designed for long-term missions, like those studying distant planets or asteroids, can have lifespans of several years or even decades. Technological limitations. Component wear and tear. Over time, the components of a spacecraft, such as its electronics, batteries, and propulsion systems, can degrade due to exposure to extreme conditions in space. Radiation damage. Space is filled with harmful radiation, which can damage the spacecraft's electronics and other sensitive components. Fuel and propellant. A spacecraft's lifespan is often limited by its fuel and propellant supply. Once these resources are depleted, the spacecraft can no longer maneuver or perform its intended tasks. Innovative propulsion systems, such as ion engines, can extend a spacecraft's mission duration by using fuel more efficiently. Micrometeoroid and orbital debris. Micrometeoroids and orbital debris pose a constant threat to spacecraft. Collisions with these objects, even tiny ones, can cause significant damage or outright destruction. Advanced shielding technologies can help protect spacecraft from these hazards. Human intervention and maintenance. For crewed spacecraft, the health and well-being of the astronauts are paramount. If a critical system fails or the crew encounters health issues, the mission may be cut short. Regular maintenance and repairs can extend the lifespan of a spacecraft, but these operations can be complex and costly, especially in the harsh environment of space. The future of spacecraft longevity. As technology continues to advance, we can expect to see significant improvements in the lifespan of spacecraft. Here are a few promising developments. Advanced materials. The development of stronger, more durable materials can enhance the structural integrity of spacecraft and protect them from the harsh conditions of space. Self-repairing systems. Innovative technologies that enable spacecraft to repair themselves could significantly extend their lifespans. Nuclear propulsion. Nuclear propulsion systems offer the potential for longer duration missions by providing a more efficient and powerful source of energy. The lifespan of a spaceship is a complex interplay of factors, including mission duration, technological limitations, fuel and propellant, environmental hazards, and human intervention. While technological advancements have significantly extended the lifespan of spacecraft, there are still many challenges to overcome. As we continue to explore the cosmos, understanding the factors that influence a spacecraft's longevity will be crucial for future missions. With that said, thanks for watching, and until next time.